I believe the previous lessons convinced you that overfitting is the real enemy when it comes to machine learning. We also said we will teach you how to deal with it. That's precisely what we'll do in this lesson. To prevent overfitting, one must be able to identify it first. Let's start with that. Usually, we'll be able to spot overfitting by dividing our available dataset into 3 subsets: training, validation, and test. The first one is the training dataset. As its name suggests, it helps us train the model to its final form. As you should know, that's the place where we perform everything we've seen until now. Nothing is new here, since so far, we thought all data is training data. But we intentionally labeled the Python variables training data instead of data in the exercises. Okay, let's check out the other 2 subsets. The validation dataset is the one that will help us detect and prevent overfitting. Let's see how that works. All the training is done on the training set. In other words, we update the weights for the training set only. Every once in a while, we stop training for a bit. At this point, the model is somewhat trained. What we do next is take the model and apply it to the validation dataset. This time, we just run it without updating the weights, so we only propagate forward, not backward. In other words, we just calculate its loss function. On average, the loss function calculated for the validation set should be the same as the one of the training set. This is logical, as the training and validation sets were extracted from the same initial dataset containing the same perceived dependencies. Normally, we would perform this operation many times in the process of creating a good machine learning algorithm. The 2 loss functions we calculate are referred to as training loss and validation loss. And because the data in the training set is trained using the gradient descent, each subsequent loss will be lower or equal to the previous one. That's how gradient descent works by definition. So, we are sure the training loss is being minimized. That's where the validation loss comes in play. At some point, the validation loss could start increasing. That's a red flag. We are overfitting. We are getting better at predicting the training set, but we are moving away from the overall logic data. At this point, we should stop training the model. Let's illustrate this with the same example we used in the last lesson. We start from an underfitting position. By increasing the complexity of the model, we reach a very good model. The training cost is going down, the validation cost is moving accordingly. At some point though, we start overfitting. As you can see, the training loss is still decreasing, while the validation loss is increasing. That's when we should stop. Alright, it is extremely important that the model is not trained on validation samples. This will eliminate the whole purpose of the above-mentioned process. The training set and the validation set should be separate without overlapping each other. Cool. See you in our next lesson, and thanks for watching.